Hello everybody, welcome to another video from MCU Park. Hope that you find my videos interesting and informative. Please, if you like my videos, consider subscribing and hitting the like button. Today we are making a lab power supply that can deliver up to 30 volts and a maximum of 10 amps. It only requires a DC input anywhere between 5 and 30 volts. The core component is a buck boost converter that you can get from AliExpress or Amazon for maximum of $13. To support input from any standard power supply or battery, we will use the standard 5.5mm power jack socket along with an XT60 connector. Those are connected to the module through a power switch on the positive terminal. To have visibility on the output voltage, a meter will be added. The power of the meter will be connected to the input power of the power supply to avoid the changing voltage of the output, while the sensing wire will be connected to the output positive terminal for measuring the output voltage. For the output, we will use the standard banana plugs, as well as XT60 connector to be able to use the power supply as a battery charger. The meter also will be used to measure the output current by connecting its current sensing leads between the load negative terminal and the module output negative terminal. Let's not forget to add a fan to cool things down and avoid overheating. The fan operates at 12 volts, so it will be connected to the input power of the power supply. The module is using two trimmers to control the output voltage and current. Each of them is 200 kilo ohms. We need to replace them with two external potentiometers for easy access. For a precise current and voltage control, we can use a 200 kilo ohms 10-turn potentiometers, but I couldn't find it anywhere. Then I decided to use two separate potentiometers, one for the coarse and one for the fine settings. The coarse potentiometer value should be 200 kilo ohms and the fine potentiometer should be 20 kilo ohms. Both are connected in series. When calculating the effectiveness of this setup using several combinations of the fine and coarse values, we can see that at low values of the coarse potentiometer, the fine potentiometer is not effective. To fix this, we need to use three potentiometers. One of them is 200 kilo ohms for the coarse settings, while the other two will be used for the fine settings. Each of them is 20 kilo ohms and controlled via the same shaft. So their wipers should be at the same value all the time. It's called dual gang potentiometers. Doing the same calculations for this setup will show us that this setup will maintain the same effect of the fine setting for the whole range of the coarse potentiometer. We will apply this solution to our module and replace both trimmers the way we see. And here we can see how to do the wiring and soldering for the normal potentiometer and dual gang potentiometer. So this is a 3D model for the final product to have an idea about what we are trying to achieve. Before start doing any modifications on the module, let's test it first and make sure that it's functioning correctly. I'm using another power supply limiting the input voltage to 5 volts and current to 1 amp to avoid any accidents. I tried also changing the input voltage to see the effect on the output voltage, which was stable till I went below 3 volt. then the output voltage starts decreasing. So the module is behaving normally and we can proceed. First thing, I will start by preparing the potentiometer's assembly. This is a dual gang potentiometer. I will fix the finished parts in its place in the container's box whenever it's ready. These are the potentiometer's assembly for the voltage and current control. Now it's time to remove the trimmers from the board and connect the external potentiometers instead. Now it's time for the input power sockets. I 3D printed this white cover for the XT60 connector to protect it while not in use. Connecting all the input and output power wires to the module and assembling the containers box. We are ready to connect the power and test our setup. The coarse and fine potentiometers are functioning properly. To test the power supply under load, I will use this motor which operates at 12 volts and can take up to 24 volts. Let me finish the box assembly before a final test. Thank you for watching, and if you have any comments or questions, please leave it down below. If you like the video, please click the like button.